In the previous sections, we talked about finding area and perimeter of regular shapes, so such as rectangles, triangles, etc. In class, we also started looking at irregular shapes when we talked about the sector. Because in the real world, often we don't encounter these perfect regular shapes, it's irregular shapes that we see. Irregular shapes are either a part of a regular shape or they might be a couple regular shapes put together or parts of regular shapes put together. What we're going to talk about now is applying the concepts of area and perimeter to one place that we might actually use geometry in our real lives, in the real world, which would be home improvement projects. So what we're going to look at, we have a space. Let me sketch it out for you. So this is our breakfast nook, okay? It's our kitchen with a breakfast nook. And we're given the following dimensions. From end to end, here's 16 feet. Here is 6 feet. This is 4 feet. As is this, okay? Now, the drawing you'll get in class when I give you this packet, this part is actually sort of a semicircle, okay? So we've got our kitchen with a breakfast nook. And what we want to do is figure out what the cost of the ceramic tile is needed to tile the floor of this kitchen. The tiles measure 6 inches by 6 inches and come in cartons of 50 tiles. Each carton costs $38. Okay, I know that's only, a couple of sentences, but that is jam-packed full of information. And if you're like me, when you read something like this, you get a little overwhelmed. The best thing I can tell you is, if it involves numbers, it can be solved mathematically. But you have to learn to take a step back from the problem and figure out what sort of the big math concept is you're dealing with. So that's the first thing. In order to attack a math problem mathematically, you have to know the concept you're dealing with. Since we want to tile this floor, think about what that is. Tile is on the inside of the space. That's an area calculation. So I think it would make sense then to start by finding the area of this space. Well, we've never calculated the area of a space that looks like this, or any figure that looks like this. This is what we call an irregular shape. But hopefully as you're looking at it, you see some regular shapes or parts of regular shapes embedded in there. What we will often do is section off the figures into regular figures or parts of regular figures that we can actually identify and work with. By drawing in that dashed line, you can see that we have a rectangle at the top and then this semicircle at the bottom. Okay, keep in mind we are looking for area. Let's start with area of the rectangle. Area of any rectangle is calculated base times height. So we have a base and height of 6 and 16. This is going to give us a total of 96 square feet. Now we need to deal with the semicircle. All right, the area of a full circle is calculated pi r squared. So let's start there. If we were dealing with the whole circle, we would need the radius of it. Well, looking at this, how can we figure out the radius? Well, from here to here is 4 feet, and here to here is 4 feet, but all the way across is 16. So that means we're missing 8 feet. Now I know what you're thinking. If you were actually doing a project like this and you needed the radius of this space, you would just take out your tape measure and measure. Absolutely. But I want to give you practice in finding measurements indirectly, such as we had to do here. Okay, so that was 16 feet, so we were left with 8 feet here. All right, well, that's the diameter of the space, so the radius is 4. All right, to find the area of the whole circle, we'll go ahead and take 4 squared, which is 16, and multiply by pi. That gives us 50.26 square feet. But we don't need that full area, because if we took that full area, we're starting to encroach or overlap with the rectangle. And we already calculated the area of the rectangle, so we don't need to overlap again. All right? We just need the semicircle here. Well, semicircles are half of the full circle, so we take our full area and divide by 2, And what we get is 25.13 square feet. All right, well, we need the total area. So total area is going to come from taking the area of the rectangle plus the area of the semicircle, and we get 121.13 square feet. Now we know the total space we need to cover. Remember what we were being asked to find, the cost of the ceramic tile. There's a lot of different directions we can head next. Every time I do this problem with a group of students, they tend to have a slightly different idea about where to go next, but we all end up at the same correct final answer. So you might have some ideas about what you would tackle next in terms of the information given in this problem. What I'm going to do, since I need to know the cost of the ceramic tile, I also know I need to figure out how many total tiles. So let me go to the tiles. Each tile is 6 inches by 6 inches. We're dealing with area, so I'm going to figure out the total area that each tile will cover. Since it's a square, I'm going to take base times height, and I get 36 square inches. Now the problem with this calculation is that my materials are in square inches, and my measurements were in square feet. At some point, we have to reconcile this. You might have wanted to convert here before you found the area and get that into feet. That would have been fine. I did not do that. So that means I have to do some work now. I'm going to go ahead and I'm going to convert my measurements, my square footage. I'm going to go ahead and convert that into square inches. This will give us a good review of dimensional analysis. Now, if I want to get rid of square feet, feet are going to go on the bottom, and I know a relationship between feet and inches. Keep in mind, though, it's not feet to inches I need, it's square feet to square inches. So this step, while it is a step in the right direction, will not give me the correct final answer, because these feet are just going to cancel out one of them. In order to convert to square feet, I need to do it again. Now that foot cancels with the other foot, and the inch times the inch will give me the square inches I was looking for. So I have to take the 121.13 times 12 and then times 12 again. In other words, I'm multiplying by 144. So that gives me 17,442.72 square inches. Just double checking that calculation. Yes. Okay. So what we have now is our material, or excuse me, our dimensions in square inches. This is the total amount of square inches we need to cover, and this is what each tile will cover. At this point, we could head a couple different directions. One logical place might be to take our total area and divide by what each tile will cover. When I do that, think about what this number is. If this is my total area and this is what each tile covers, then this 484.52 is the number of tiles I need. Okay, we're getting closer. I now know how many tiles I need. So looking back at the problem, we see now that we can't buy individual tiles. Tiles are coming 50 to a carton. So really, we need to figure out how many cartons we have to purchase. If we take 484.52, that's the number of tiles, and divide by the number of tiles per carton, we get 9.69. That's the number of cartons we need. So stands to reason that if we need 9.69 cartons, we're probably going to buy 10 cartons. At $38 a piece means we are going to spend $380. Now this problem was quite involved. It really encompassed everything that we talked about, from dimensional analysis and converting units, and then from our area and perimeter section. we're going to look at some other problems in class that do not have all of these things embedded in them. Some of them will have, you know, a couple, each one will have just a couple of things as part of it. But we did this one together so you can see how sometimes you have to use a lot of the things you know to solve a problem. Other times it's just, you know, one or two concepts within there. So in class we'll be looking at some other irregular shapes and applications of area and perimeter as they relate to these irregular shapes and home improvement projects.